This is yours, sir.
Mind your comments. Yeah.
All right, so here's the next one. If we follow the rule for natural log, what's the derivative of this?
1 over x, right? Or
Well, okay, the steps,
So
so
12x squared
12x squared
minus 2x
minus 2x over
the 4x cubed minus x
minus x squared, okay? And then you could see if you can factor anything out. And so on top, to simplify this, on top you would see that this is, there's an x,
You can take out a 2x.
12x minus 2, and then an x here. So then you get 4x minus x. And then those x's cancel out, so it leaves you with 12x minus 2 over 4x minus x. So that would be your derivative.
But wouldn't that be 4x squared? Because you're only taking 1x out, right?
True. So then, there you go. 4x squared. Okay, so then,
Oh, I was like.
yes.
To the third.
So there's your derivative. Okay, so the key, okay, is again, the rule. Okay. You could, but nothing will cancel. So then, more than likely, just leave it there. Okay, yeah, you could take out another x, true, but there's nothing gonna cancel. All right, so for what we do is we wanna rewrite, so I can rewrite 8x to the 7th minus 10 as to the power of 1, 8. Okay, that's the rewrite. And then I wanna take the derivative of that. Okay, so guess what? It's gonna be the power rule.
Yes.
Okay, so what's it gonna be? 1/8
times 7.
8x to the 7th minus 10 to the
Or 1.
That's gonna be 8, 7, 8.
Negative 7.
negative 7/8,
yeah.
right? So you subtract 8 over 8
Yes.
times the derivative of 8x minus 7 is 56x to the 6th power, right?
Yes.
And I can multiply 1/8 times 56 is 7. And I'll go ahead and move the x to the 6th to the front as well. I could also rewrite this as a fraction because it's negative. 8x to the 7th minus 10 to the power of 7 and the 8th root. Okay, one of the ways you could write it.
What happened to the 1/8 that was out in front?
1/8 times 56 is 7.
Okay.
However, you could be asked either way, right? You could be asked either way. So if it's multiple choice and you don't see something here, guess what? It's probably gonna be this, okay? Or if it's a free response and they don't say in a particular format, then you're good right here. Okay, right, so, but of course, you probably want to multiply 1/8 times 7. Okay,
So then it would be like this one. The bottom one, okay.
yeah, which is what we have. And you'll notice on that, yeah, good point. So you'll notice on your answer choice 2, although my math lab should take both, would be 7/8. Okay, that's what it says on your answer choice. That's equivalent as well. Okay, that's equivalent as well. Okay, all right, next one. Let's look at number 5, implicit differentiation. So with this one, you're gonna take x cubed plus y cubed equals to 5, but we're gonna take it term by term. With respect to x, so meaning what's the derivative of x cubed?
3x.
3x squared. With respect to x, it's just gonna be 3x squared. What's the derivative of y cubed?
So 3y to y prime.
3y squared times y prime. So anytime you take the derivative of y with respect to x, you gotta put the y prime. And derivative of 5?
0.
0. So next, the strategy is, we wanna solve for y prime, which here's a note here. Y prime is the same thing as dy dx. Okay? Because that's what the question is actually asking. Solve for dy dx. Okay? Which is y prime. So get all the non-y prime terms to the other side. So that would be minus. And then what?
You divide.
Divide. Y prime, or divide by 3y squared. So it's negative 3x squared over 3y squared. The 3's will cancel. So you end up with negative x squared divided by y squared. Okay, and that's your answer. So that's number 5, using implicit differentiation. So number 6. Is another one with implicit differentiation. So you have 2xy minus y squared equals 1. So who can tell me what rule this uses here? Product rule, right? 2x is your first, y is your second. So hopefully you know the product rule verbatim, right?
The first and the second.
Yeah, so that's the root of the first is
2.
2 times the second unchanged,
Y.
y, plus the root of the second,
Y prime.
y prime times the first 2x. So that's we found that derivative. The derivative of minus y squared.
I'm still,
Oh,
2y.
2y
times y prime.
times y prime. Okay, because this is with respect to x. What's the derivative of 1?
0.
0. What do I want to do? Leave all the y primes on one side, take everything else to the other side. So subtract 2y, y prime 2x. I'll go ahead and move the y prime to the front. Doesn't make too much of a difference. And then this will be minus 2y over here, because I'm going to take that over. Who remembers what's next?
Don't you take a divide? But you can take
Well-
out the Y prime.
Yes, well notice that there's a y prime here and a y prime here. So we're going to factor out the y prime. So what are we left with? 2x minus 2y equals to negative 2y. Okay, because there's a y prime here
Okay.
and a y prime here, I can factor it out. So now I'm left with inside 2x minus 2y. So now what's the final step? Divide. Okay, we're going to divide by 2x minus 2y. So y prime equals negative 2y, 2x minus 2y. Now here's a shortcut. If you ever see something, if everything has the same term or factor, I can divide everything by that factor. So what can I divide everything by here?
2.
I can divide everything by 2. Okay? It wouldn't work. It wouldn't work if this was like 3 and these were 2. There's no point if you wouldn't do that. So the answer here,
It's negative.
negative y over x minus 1.
right? Negative y over x minus 1. Okay, so that's our answer there. Okay, good.
Just on the answer key, sir.
What's that?
It doesn't have the negative y. It just says y over y minus x. 6.
Okay, well, good point. Now, yeah, so maybe your answer choice might say something different.
You know it will, because he's gonna get 5
You
answers.
could actually, now this is accurate. Okay, so this is accurate. There's always other ways to write stuff. Okay, so what if we factored out a negative here? Okay, so here's a very subtle thing. Factor out a negative, all of a sudden that becomes negative x, and that becomes plus y. So does everybody see that these two are the same?
Yes.
Okay, but then what happens with these two negatives? I can cancel out, and then you get y equals y minus x. Okay, so then that's also another form of it. So if you come down to this, and you see this as your answer choice, and you don't see this, well there's a reason. You got, this is the additional steps. Okay, or that's the additional step that you could actually factor out a negative there. Okay, but like I said, that is an answer. Okay, it's just maybe not in the form that's asked on the test, but, okay, so let's move on. Number 7, we have implicit differentiation. Okay, so this one says x cubed plus 3x squared times y plus y cubed equals 8. You know what? Yeah, I'll try it. Yeah, let me try it. Go ahead.
Yeah,
Okay.
we're being recorded when you left the
So,
room.
3x squared, if I take this derivative, plus, what rule am I using here? Product rule again. So, I'm gonna take, the derivative of the first is
6x squared.
6x times
Y,
y, plus the derivative of the second,
Y,
y prime, times the first unchanged,
yeah,
3x squared,
I forgot product.
plus, what's the derivative of y cubed?
3y prime, or
3y
3y times y prime,
Squared y prime, what's the derivative of 8?
0.
0. Okay. Follow the same procedure. Leave all the y primes on this side. Take everything else on the other side. So y prime times 3x squared plus, I'm going to write the y prime in front, times 3y squared.
That's why.
Move that over. Move that over. Okay.
Okay, hold on, stop right there.
Okay.
What's that? It looks like you opened the parentheses. I don't know what you did.
I meant to close it, but you know what, it'd be better if I just take it out. Okay, it's times. I just moved this to the front. I moved the y prime to the front.
Oh, I'm right.
You don't really have to do it, but I like to do it. I'm gonna pull it out on the next step.
So now,
Right?
Take out,
So what's next?
You're gonna take out the y prime.
Factor out the y prime. Okay, so we're gonna factor out the y prime, and that'll give us 3x squared plus 3y squared equals to negative 3x squared minus 6xy. Okay, then what?
You divide by the stuff inside the parentheses and leave the y prime by itself on the left side of the equation.
Okay, I'll take that. Minus 6xy over 3x squared plus 3y squared. And that's your derivative, or in other words, dy dx,
The
right?
G's? Cancel out the G's, huh?
Well, you can
Yes,
divide
actually.
by-
Yes, okay, good. So I can divide everything by 3. So that'd be negative x squared minus 2xy over x squared plus y squared. Okay, good call. All right, so that's 7. Okay. Let's do find the equation of tangent lines. All right, let's do 8. Okay, then I might kind of skip around and do this. Okay. Okay, so 8.
So we gotta factor out. So we gotta factor out the negative too, right?
Here,
Show you.
this- Go ahead.
Or no, I'm sorry, put it on the bottom. Or, yeah, put it in the
Yeah, okay, so here, other forms. Okay, other forms. There's always other forms. You could also factor out, if you notice in the back, you can factor out the negative as x squared plus 2xy over x squared plus y squared. That's equivalent, because it's like you're distributing the negative into the top. Okay, so this is equivalent to that. Okay, but again, if you're finding the derivative, that is it. Okay, but this is another form of it. It's the same thing. This is back to basic algebra. You're distributing the negative. Okay. Any question on that?
You just distribute
Yeah, it's just distributing the negative into. Or it's in other words, it's almost like factoring out a -1 too as well. Okay. All right. So let's look at number 8. Okay. Which says find the equation of the tangent line.
X is equal.
When x equals to -4. Okay. So the first part, I'm gonna leave it to you. You do the same thing, okay? So you do the first part. Find y prime.
So you gotta find the,
The implicit differentiation. Yeah, that's what this is called. Implicit differentiation.
it's because of the y there?
So it'd be the product.
Why is that?
Because without the y, what is it called? Derivative, right?
When it's y equals is what you mean. Yeah, that's we call it to take the derivative, and usually when it's y equals, it's explicit.
Yeah.
Yeah.
So use the product.
On here, you'll use the product minus. Okay. All right. Go ahead. Okay, so take all the y prime, or leave all the y primes on one side, take everything else to the other side. So we end up with y prime times 2y plus y prime times negative x equals to y. Okay, equals to y. Two y squared. Okay. And then from here, yeah, go ahead.
Shouldn't that second plus be a minus?
This one?
The one on in the middle. Right there, up, right there next to the y, between two y's.
Right. This one? Right there.
Shouldn't there be a minus?
No, because it's the derivative of the first is 1
And the
times the
second
second
is
change.
minus.
Plus, because it's product rule, the derivative of the second, which is y prime times the first unchanged, is negative. Now, yes, it'll turn to minus here because of this, but I can write that here if I want.
No, don't change it.
But this is good. This is fine. That's fine. Okay. Unless I'm missing something. But 2y times y prime. Yeah, it looks good. 2y times y prime minus y plus y prime x times negative. Yeah. Okay, now what? Factor out y prime. Y prime. Then you get 2y minus x equals y. Okay. From here, divide y over 2y minus x. Okay, y over 2y minus x.
Yeah.
Okay. Okay, and then from there, now this is where it's different. Okay, so so far that was the same as the previous two questions. Okay, so the part where it's different is it says find the slope of the tangent line when x equals -4. You're gonna have to plug in -4 and figure out what y is. So y squared minus -4 times y plus 3 equals 0. Which this will give you y squared plus 4y plus 3 equals 0. How do you solve this? You gotta factor. Y minus y plus 3 and y plus 1. And then so what are the solutions? -1
-3.
and -3. Okay? Okay, so all I've determined from this is that I have coordinates at -4, -3, and -4, -1. Okay, so I've had these coordinates. We haven't done these tangent ones in a bit, but here you actually have the y minus 1 equation, y minus y1 equals m times x minus x1. Okay, and we have to determine the slopes. Okay, so from here to determine the slope, this is the slope, the derivative. How am I going to get the slope at this point? Plug it in. Okay, plug in this x and that y into here. So that would be slope for y prime. You can say this evaluated at -4, -3. That just means plug in those values in here. So that's negative 3 divided by 2 times negative 3, negative 3 minus negative 4. Which would be, this is the final slope. This is negative 6 plus 4. Negative 6 plus 4 is negative 2, so that's negative 3 over 2. So that's 3 halves. So again, what do? We determine the point when x equals to negative 4. We plug this point in to my y prime, which is my slope. And we got the slope is, in other words, this is m. It's 3 halves. Okay, m is 3 halves. So I'm going to have you do the same exact thing for the other one because I'm only doing it for one. So here I have y minus, if I'm looking at this point, that's my y1. So y minus what? Negative 3 equals to 3 halves times x minus
Negative 4.
negative 4. That turns to plus 3 halves x. If I distribute 3 halves x, 3 halves times 4 is 6. It's 4 divided by 2 is 2. 2 times 3 is 6. And then subtract 3. Okay. So there's a lot going on there, but I think it's a pretty good problem for understanding purposes. So I want you to do the same thing for that one. So you're gonna plug these values into your slope. Find the slope, and then you're gonna plug in that x1 and y1 into the point slope formula along with the slope that you find. Okay, so do that. So plug these values into your slope equation. This it's the appropriate y or x. Get the slope, and then plug in your x1 and your y1 in here. Okay. All right, try that. Okay, so that's how you would do 8 there. Okay, so number 9, it tells you that you have the equation x squared plus y squared equals 25, and they start talking about x equals x of t, y equals y of t, and you want to find dy dt, or when dy dt equals 3, x equals 3, y equals 4. So there's a lot of details in here. Dy dt equals 3, x equals 3, y equals 4, and we want to find dx dt is the question. So this tells me I want to take this derivative with respect to t, okay? Because that's the only way I'm going to get a dx dt. So with respect to t, now what's the derivative of x squared?
2x.
2x times dx dt. Okay? What's the derivative of y squared?
2y.
2y times
y
dy
dt.
dt. Derivative of 25?
0.
0. Okay? So I could actually solve this from here because I have 3 of the 4 variables. I can go ahead and plug them in, right? And then I can solve for the final variable. So 2 times 3
Times 3.
times dx dt is unknown actually,
Yeah.
right?
Excuse me.
Plus 2 times
4.
4 for y times dy dt is 3 equals to 0. This is 8 times 3, that's 24. That's 6 dx dt. Oops. 6 dx dt equal to 0. Subtract 24 divided by 6. That's negative 4. Okay, so we've solved for dx dt. Okay. Should we do the next one?
Hold on.
Okay, so that one's solved. Let's, sure, we'll do 10.
Well, I'm doing it. Oh, that's why dy dt is 3, that's why.
No,
Okay.
It's gonna be 3.
I'm gonna note that one as well.
So it's gonna be 2 times, it's gonna be 60 x dt.
Okay, so let's try the next one. So x squared y minus 6 equals 12y plus 3. It's very similar. This one tells you dy dt equals 2, y equals 12. Okay, so the only way, because they're asking for, again, dx dt, the only way we're going to get dx dt is to do what? To take with respect to t. I have to do it with respect to t. So we'll do that, but this one might benefit from a rewrite.
Okay.
Yeah, maybe like x squared y minus 6x squared equals 12y plus 3. Okay, and then I'll take the derivative. Okay, so I rewrote it before I'm going to take the derivative. So I just distributed the x squared. Okay.
Okay.
So I have a product rule here. So I have 2x dx dt times y, the derivative of the first times the second unchanged, plus the derivative of y,
Or y, dy.
dy dt times the first unchanged, x squared. Because it's with respect to t this time. It's with respect to t. When it's with respect to x, then it's just normal, or like regular derivative. What's the derivative of negative 6x squared?
12x.
12x
dy, dx.
dx dt. What's the derivative of 12y? 12
dy, dt.
dy dt. Okay? From here, just plug it in. Right? So you can just plug it in from here. So, plug in what you know, 2 times what?
X is 5.
5 times dx dt
Dx
is
dt
unknown.
is unknown.
Y is 12. dy dt
2,
2x
5,
5 squared minus 12 times
5.
5 dx dt unknown equals 12 times 2. Okay, that would be 10 times 12, that's 120 dx dt. 5 squared is
Shouldn't that be
20.
a wait, what happened? Well, shouldn't there be a y? I thought there was a y somewhere in that second dx. Why isn't there a y there?
Right here?
The second
Yeah,
one, sir.
that's 12.
That's the 12, but after the
That.
first, yeah, right there. What happened? Okay,
Minus
the derivative, the first
dy.
time,
Derivative.
okay.
Y is a D.
The dy, dt is the respective.
Yeah, that, when you took the derivative of 12y, that's became dy dt.
No, I was talking about that second, right after the first plus sign.
You saw
The
dy,
first plus
dt,
sign,
x
yeah, right
squared.
there.
This one?
dy over
Okay.
dt x squared.
This is the product rule, because the derivative second is dy dt
I can't
times
respond.
the first
Second.
unchanged.
First and change, okay.
Yeah. Okay, so where were we? We multiplied all this. 120 dx dt plus 25 times 2 is 50. Minus 60 dx dt
dx dt is.
equals 24. 120 dx dt minus 60 dx dt is 60 dx dt. Subtract 50, you get negative 36, and then divide by 60. Negative 36 divided by 60, you can reduce that by 6, a factor of 6, should be negative 6/10, which could also reduce to, well here, let's reduce it by the bigger number, reduce it by 12, which would be negative 3/5. Okay, it'd be dx dt. Okay, so that solves that.
Which problem is
Number
10.
number 10. You know what? It's
So you got something
It
different.
says
Yeah.
negative 32.
50 minus 24?
Yeah.
Oh,
Oh,
no,
which
no,
is
no.
26.
26,
Right?
yeah,
That's
yeah.
26. Okay. Then that you'd have to reduce by 2,
Which is
13 over
30.
30. Yeah. Okay, that fixes it. Okay, good. Good call. All right, so that fixes it. All right.
So then the top one, then negative 26.
Yeah, that's fine. It is, the problem was,
Oh,
yeah,
yeah.
we didn't subtract 50 yet, right? So that should be minus 50, that's negative 26. 24 minus 50. Okay, good. All right, so let's look at, what else? 11, okay. 11. What's going on here? Okay. All right, so 11 you have in front of you. 11 says, suppose two automobiles leave from the same point at the same time. If one travels north at 60 miles per hour and the other travels east at 45 miles per hour, how fast will the distance between them be changing after 3 hours? Okay, so first I would probably draw the situation for 11. Okay, so automobile A travels north at 60 miles per hour. So speed indicates a rate of change. Okay, which is like a d. I'll call this y, and I'll call this dy dt. Okay, and then car B goes east at 45 miles per hour. So I'll call this distance x, and I'll call, what am I going to call the speed? dx dt. So that's the speed going in that direction, which is what? Equal to 45. Okay? Now, they want some relationship between the direct distance between car A and car B. What shape do you see here?
A triangle.
Specifically, a right triangle. So you can set up a relationship by x squared plus y squared, right? And not only that, after, they're asking for after 3 hours. Well, who can tell me after 3 hours, how far did this car travel?
180.
180, 60 times 3, right? 60 miles per hour times 3. So that's, in other words, they want to know when y is 180, and also when x is after 3 hours,
135.
135. 45 times 3. 45 times 3. Okay? So, and as well, we kind of have a second equation. We have another equation. The direct distance, the distance between the two is set up by the square root of x squared plus y squared. Is everybody okay with that? No? That's, if this is the distance, here, I can take it a step before.
Okay.
Right, the step before would be, I'll get to that, I'll write it again, but the step before would be set up the Pythagorean theorem is going to equal to the distance squared. Right, so then if I want the distance, and I'm going to move it over here as well, I'll take the square root of these two. Okay? So that's my setup. I want to, well, could I leave it at this? I could possibly leave it there. What's easier? Yeah, we can do that. Okay. So here, what I could do is set up d equals, if I want to rewrite, x squared plus y squared to the what power? To the 1/2 power. Okay? I'll just rewrite it. Now I will take the derivative, which is with respect to time. So d dt, okay, equals to 1/2 x squared plus y squared to the negative 1/2 power times 2x
Plus
dx dt plus 2y
dy dt.
dy dt.
I got one.
Okay, and then from there I can just plug stuff in. Okay, x squared plus y squared. So I could plug in 60. Oh, give me 1 second. I can plug in 60. I can plug in y. I can plug in x. and I could plug in x in here, y also here, and dy dt into here. And then what are we looking for? We're looking for how fast will the distance between them be changing after 3 hours. Yeah, basically we just plug it all in. Okay, so you'll have a calculator, right? So here's by, if we're to write it, or what you would put in the calculator would be 1/2 x would be 135 squared plus 60 squared to the negative half. Yeah, 60 squared. Times 2 times x, which is 135, times dx dt, which is 45, plus 2 times y, which is 180. Oh, I see what you said. 60, yeah, okay. It should be what? 180, because that's what we said y was. Okay, so that should be 180. 2 times 180 times dy dt is
Oh, wait.
60.
Yeah.
Okay. Okay, and then I wouldn't do any more work after that. I would just type it in. Okay. Okay, so, all right, I'll type it in and you try to type it in as well and see if we get something that matches.
So it's gonna. So which one are you doing first? Let's go plus. Wow. Someone doing around one.
Okay, that gives it to you. Okay. 75.
0.004.
Okay.
You want to take it to the 10th or 100th place?
I got 75.
Well, I'm talking about the doing the multiplication parts.
What do you mean?
Well, when you do that 135 squared plus 180 squared.
Oh, I wouldn't even do that. I would just, I literally.
Oh, you just enter it just like
I
that?
typed it in like this.
Yep.
Yeah, I typed it in like this. Okay, I wouldn't do any more than that. Okay. Yeah, I got 75. So if you type it in like this, you should get 75. You what?
I said miles per hour.
Miles per hour.
Tomorrow. 8 o'clock is going.
Okay. Let's move on. So number,
Yeah, okay, sure.
we're gonna try, we'll see if we can get to some more.
Yeah.
Okay.
No point. We're going to something.
Number 12. Okay, so number 12, you have x equals f of p, which equals to 30 times 15 minus p. It says use the demand equation to find the revenue equation. So revenue, okay, here's the formula you'll need. Revenue is basically equal to x times the number of items you have times the price of the items. Okay? That's revenue. So that'll be one for your formula card. Okay? So basically that R of x equals x times what? Times p. Okay? And that's basically it. You might want to clean it up a little bit. 30 times 15 is 450 minus 30p times p is 450p minus 30p squared. That's my revenue. Okay, so that basically finds it. Okay, 13.
Hold on.
And this will be good ones to leave off on. Okay, so here, I'm gonna kind of overwork this one a little bit, because they give you the critical points, but I'm gonna kind of review that real fast, because I think it'll benefit you. How do you take, so how do you find critical points? You take the derivative, right, which is 12x squared minus 48, set it equal to 0, solve for x, divide by 12, I'll get 4 equals x squared, and
Which is
therefore
2.
you'll get -2 and +2, which is given in the problem. They gave it to you, okay? But I'm just reviewing it, okay, to show you where it came from. Okay, because you might have to do it. You will have to do it. Okay, listen, you will have to do it. So, so now it says, use the first derivative test to determine which of the critical values correspond to the local minimum. So what's the first derivative test? That's where you're going to take your interval, right? Then you're going to find some test values, and then you're going to plug them into f prime, and then you're going to determine whether it's increasing and decreasing. Okay, so the intervals would be what?
Negative infinity to -2,
-2,
and then -2 to 2,
and then
2 to infinity.
okay, so then you just pick values in there, so like -3, 0, 3. Plug those into the derivative. I've shown you a lot of ways to do this efficiently, to substitute, so you don't have to spend too much time here. Which, let me see if I can do it. 12 times x squared minus 4. I can plug it in that way. That's 9. 9 minus 4 is 5. 5 times 12, that's 60. Okay, you don't have to do that, just put in the calculator.
Okay.
That's -48. That's going to be the same thing as this one. Okay, so all I gather from this is that this is what?
Increase.
Increasing,
Increasing.
decreasing,
Increasing.
increasing. Okay, so this is a what?
Max.
That's a max. This is a
Min.
minimum. Okay, so it says to determine the critical values that correspond to the local minimum. Which one corresponds to the local minimum?
2.
2. So x equals 2 is a local minimum. They could have asked you both.
Yeah.
Okay, could have asked you both. Now, just on that one, here, you know what? Let me skip. Let me not do 12. Okay, and just to kind of get something I think that's more important, let me continue with this. Okay, because that's the first derivative test. What we've been talking about is the first derivative test. That's it. And we also talked about the second derivative test.
Okay.
So the second derivative test would be 24x. 24x.
Yep.
Okay. What would you do? You need to set the second derivative equal to 0. Okay. So then you're going to get x equals 0. So that's your. That's how you're going to create your intervals. Okay. So interval test. Yeah, negative infinity
To 0.
to 0. 0 to infinity, pick values, -1, 1, f double prime. So that's going to be -24, that's going to be +24. What does that tell me on the second derivative test?
Concave down or concave.
Yeah, concave down, concave up. All right, what's this one?
Down.
Concave down. This one,
Concave up.
concave up. Okay, so we've done that enough. And then now additionally, what does this tell me? Because this goes concave down and that goes concave up, what is,
It's a input.
that's a what?
Inflection.
Yeah,
Yeah.
point of inflection. Okay, at
0.
x equals 0. And you could also find the y coordinate by plugging 0 into
The main.
here, which the y coordinate would be 0, 24. Okay, and then you could also, you have 0, 24, you have a max at 2, you can plug that in. Okay, 2, whatever that is, and you can find the min at -2, whatever that is. Okay, and I don't think I'll have time to graph it, but you can get all those points and you would wrap it, which you will be asked to do, so you might finish this problem. Okay? Yeah. So that as a free response, yes, like I told you. Okay, so other than that, I can tell you that this is gonna be pretty good.
13, right?
That was number 13 still, yeah. Okay, I overworked 13. Okay, we were done here actually.
We
Okay.
extended it.
Is that-
I said we extended.
Yes.
Yeah.
Okay, so Professor Scott will be working on the rest of them with you, okay?
Sure.
In the recitation. But like I said, this is, if you understand this, you're pretty good.
Which we did.
Okay.
Hey,
I don't understand.
I'm pulling a D
Good, good.
after this test.
I would, yeah, I mean, if you started it, it helps. But I didn't like it because it was too busy. It was too,
But you still want
I didn't
the,
want the multiple choice on there, and it came on there.
but you still want the review done, right?
The online, yes, I've told you that for a couple weeks.